Part 2 of lesson 2.7 is on rational inequalities. And so if you take a look at what we have here, we have a fraction, and it's in a factored form, and we have to identify when it's less than or equal to 0. So the first thing I'd like you to do is I'd like you to enter this on your graphing calculator and take a look at a graph. So do that now. So in entering that into the graphing calculator, I used the fraction function and use parentheses. If you're not able to use that fraction function, you'll have to use multiple sets of parentheses. But in doing it, you should get a graph that looks something kind of like this. So if you're not getting a graph like this, then probably need to include more parentheses. Okay? So now with this in mind, let's go back to the problem. The problem is asking us, when is this rational function, when is it less than or equal to 0? So there's a couple of important points here. What we need to do is figure out when it's below the x-axis and when it hits the x-axis. So obviously there's a x-intercept right here, and then all of this would be below the x-axis. And then it looks like there's an x-intercept someplace in there, and then it looks like it's below the x-axis off to the right. So keeping that in mind, let's try to locate these two x-intercepts. Okay? So one way to do it with the graphing calculator is to go second trace, which is the calculate feature. We're going to use option 2, which is finding the 0. Press enter, and it gives you a blinking cursor that you can move. I'm going to move it way off to the left, and you notice at the bottom it's asking us to put the cursor left bound. That means on the left side of the x-intercept or left side of the 0. I have it there. Press enter. Then it's going to say put it on the right side, make it right bound. So I'm going to move the cursor to the right side of the x-intercept, like here. Press enter. Then it's going to say give me your best guess. I'll move it closer to my best guess. Press enter, and it calculates the 0 for you, and that appears to be at x equals -2. That's going to be an important point. So let me write that down. X equals -2 is a 0. By the way, pay attention to this factor right here. Okay, now we'll find the other x-intercept. So I'll go second trace, which is calculate. Go to the 0 option. Now I'm going to move the cursor over to the right, and it's wanting the cursor to be left bound. I'm going to get a little bit closer to that x-intercept. Press enter. Now it's asking to put the cursor right bound on the right side. And that should do it. Press enter. Give me your best guess. Looks like it's someplace about right there. Press enter. And it calculates the other x-intercept. Looks like it's at 3. This is an important point. Let me come back here and write that down as well. X equals 3. Also pay attention to this factor. So, from looking at that graph and looking at these two x-intercepts and looking at our inequality, hopefully you've figured out here now that the factors in the numerator help find the x-intercepts. So with that being said, how are we going to answer this problem? We need to give all of these points and then all of these points for a solution. Okay? So, this is the other piece that we need to be aware of. There appears to be a vertical asymptote right there at -1. Okay? That's an undefined value. The graph appears to be getting closer and closer to that vertical asymptote at -1, but never touching it. How do I know that? Well, if we go back to the inequality, take a look at this right here. The factor on the bottom will help you identify your vertical asymptotes. So, we're going to say from -2 to -1. Now we're going to put a parenthesis on the -1 because there's a vertical asymptote there, which means we cannot put that number into this function and get an output. If we tried putting -1 into this inequality, we get a 0 on the bottom and you can't calculate it. I'm going to put a bracket on the -2 because of this part of the inequality, the equal to part. If it didn't have the equal to part, this would be a parenthesis there. So that was the first region. Now the second region, off to the right, we're going to go from 3 to infinity. We always put a parenthesis on an infinity. And again, since we have the equal to part on the inequality, we got to put a bracket on that 3. This would be our solution to the rational inequality. Let's try a couple more using the graphing calculator. It tends to help us a little bit. So next one. Why don't you take a moment and enter this on your graphing calculator. Again, in entering this rational problem, if you can use your fraction function on your calculator, do that. Otherwise, you have to use a bunch of parentheses. So everything that is on the top is in front of the division symbol, and everything on the bottom is in parentheses behind it. So I have it entered, and now we go to graph it, and we're going to see a graph that looks something kind of like this. If you don't see a graph that looks like that, that means you probably need to include more parentheses. Okay? So let's go back to the problem. They want to know, when is this rational function greater than or equal to 0? When is it above or on the x-axis? So as we look at this graph, it looks like all of this is above the x-axis. All of this is above the x-axis. And then it appears like this point right here touches the x-axis, so we need to include that. Okay. Now, a little bit more. I'm guessing we have some vertical asymptotes here. And it looks like maybe at -1. And then it also looks like maybe right at 0 are the two vertical asymptotes. If those are the vertical asymptotes, that means the bottom should have a factor of x plus 1 and at x. And you can see that as well. So, there's one more thing I'm going to have to point out to you guys. Let's go back to this, and I'm going to rewrite this rational inequality in a factored form and show you guys something. Oops, that's a -1 on the top. So there's the top written out, and here's the bottom written out. Okay. Now do you notice that there's a common factor on the top and the bottom? X minus 1 and x minus 1. What that means, you guys, is that there's a hole in the graph at 1 comma something. Okay, what do I mean by a hole? Well, I want you to turn your textbooks to page 271 and look at the graph on page 271. There's a hole in that graph. Now, I wish they didn't introduce this in chapter 2, but they do. We're going to talk more about holes in graphs in chapter 4, as you can see on page 271. But if we go back to the graph, you won't see a hole at 1, but there is. Okay? Watch when I use my trace feature. I got a blinking cursor that I can move. Okay? Move it around. And as I get closer to 1, you don't see a hole anywhere there, do you? But watch what happens when I type in it at 1. It gives me no output, no y value, which means that there's a hole at 1. So if the calculator had the ability to, go right here and make a little hole right there, they would do that, because that's what's happening right there. So keeping that in mind, how are we going to write our answer? Oh, let's also find that where that hole is at. Let's go back to trace. You can see as you're really close to 1, it's really close to 4.5. So I'm just going to approximate that hole to be at about 4.5. Okay? Now, how are we going to write our answer? Negative infinity until we get to this first vertical asymptote at -1. I always put a parenthesis on an asymptote. Okay? Then, we've got another region. Let's see here, it looks like from 0 until we get to that hole, so from 0 to 1, I always put a parenthesis on a hole, and then it looks like there's another region and that's from 1 to infinity. It's above the x-axis. Now the only thing that I didn't consider here is this point right here. So we need to find out if that's touching the x-axis right there. So let's use the calculate feature, and let's calculate the 0 if there is one. And put it on the left side. There we go. Press enter. Put it on the right side. There we go. Press enter. Best guess. And it looks like there is a 0 at -1/2. So we got to consider that into this. That at -1/2 we need to include that. So let me kind of draw a line through this, and this would be our final solution. -infinity to -1 unioned with, there's just a point at -1/2, unioned with 0 to 1, unioned with 1 to infinity. These are all the points that are on the x-axis or above it. I know this is challenging stuff, but using your graphing calculator can help, and you're going to have to struggle through this a little bit, and I'll try to provide some more assistance when I'm back at school. Alright, here's the homework problems that you're going to be working on. This is going to be collected on Monday. That's right. Have a good night.